and I went to Nepal to do research into how engineers can overcome the problem between design and implementation of seismic resistant schools in rural Nepal. So I'm going to start off telling you about what inspired me to apply for the Pai Lin Li Award and why I chose this particular topic. I'm then going to talk to you about some of the problems in implementing earthquake resistant design and some of the solutions, and I'll then take questions at the end. So firstly, why did I apply for the award, and why did I apply to look into the problems in implementing earthquake resistant engineering? In my first year of university, I volunteered for a project that involved designing and then travelling to Nepal to build a small earthquake resistant school. I was only in my first year of university, so I wasn't very closely involved in the design, and I also managed to skip most of the fundraising that was going on. So although I wasn't really that involved with it, as it got towards the end of the year, all the people who were more senior than me in the team dropped out for a variety of reasons and left me and one other person to travel to Nepal alone to build the school. The other guy who I travelled with, well no, I didn't travel with actually, the other guy who was going out to Nepal to help me, he was the master's student who designed the school, so he was quite well qualified for this job. I hadn't been involved in the design and was a first year engineering student, so obviously was not too well qualified. So me and him sat down that summer before we went out, and we worked out it'd take about 8 weeks to do it. So I was going to go out for the first 4 weeks, and then he was going to come out for the second 4 weeks, and in that time we thought we could build this school. So when I set off that summer, I was quite confident because we had all the money, we'd done all the structural calculations, we'd produced the drawings, and I had 1 year of engineering knowledge behind me. So what could go wrong? So I thought, everything. So it turns out everything went wrong. The project was an abject disaster from start to finish while I was there, and also while my colleague was there. We had landslides that stopped us getting any materials to site. The building materials we'd designed the school with couldn't actually get sourced anywhere in the district when we got there. The only translators we had were some university students, and they got bored after about 3 days of the 4 weeks that I was there, so went back to Kathmandu, so the rest of the time no one spoke any English. The labourers we employed couldn't read our construction drawings. I'd never seen drawings in their life before, and they also couldn't lay concrete blocks, and as we were trying to get them to build a concrete block school using our drawings, it was not a smooth process. The labourers went on strike several times. There was huge divisions in the community that sometimes resulted in physical fights happening on site, and these physical fights would be a result of conflicting local politics, huge divisions due to the caste system in the community. We also had big problems with corruption. A lot of the senior people there expected a big part of the project budget to allow us to work there. But despite all these community divisions and everything that they disagreed on in the physical fights, the one thing they did all agree on was Nepal does not have earthquakes, and they strongly resisted all the earthquake-resistant features of our design. They saw it as an unnecessary expense and an unnecessary complexity, and they kept on saying to me, if you give us the money, we can build 4 of our own schools in half the time. And they proved that point to me. In the time that I was there for 4 weeks, we just about struggled to dig the foundations of the school. And in that 4 weeks, they built a unreinforced stone masonry school from top to bottom next to me. So this is the kind of typical construction in the village. It's unreinforced stone masonry with mud mortar, because they're the only available materials. Same, this is a more grand version. This is where the village leader lived, but again, it's stone masonry and mud mortar. So I left after 4 weeks, and we'd got to about there. That's me. So we dug the foundations, and we were just starting to lay the first set of blocks. Because the labourers couldn't read the drawings, everything had to be demonstrated on site, so you had to do a sort of like real-life mock-up of everything, including the concept of the rebar going through the concrete voids, because that just couldn't come across in the 2D drawings. My colleague came out and was there for another 4 weeks, and I think he got to the second course of block work. And he left, and then we handed the project over to another NGO in Nepal that we had some loose contact with, and they finished it 2 years later. So that's it in 2014, a tiny little shed, but took 2 years to build, and I think it came in 4 times over the budget that we planned it to be. So it's reinforced block work, so it's got vertical steel in the corners, and it's got the wall intersections, and it's also got it around the windows and around the doors. And it's got 4 RC ring beams, one at foundation level, one below the windows, one above the windows, and one at the roof. And this holds the building together in the event of an earthquake. So I went back to university after that 4 weeks. It was by far the most 4 stressful weeks of my life that I'd had. Vowed never to return to Nepal, thought I'd never get involved in development work again. I was completely disillusioned with it because by the time I left, they'd pretty much convinced me that we were wasting our time and money to build an earthquake-resistant school when they can just build it all out of unreinforced stone masonry themselves for a lot easier. But then in 2015, you probably remember it was in the news, Nepal was hit by 2 massive earthquakes. The epicentre of the second one, which was 7.3 on the Richter scale, was about, I think it was 10 miles or something from Sunkhani, which is the village that we were working in, where we'd built the school. And the whole village was completely destroyed. I went back in January this year for the award, and not a single building was left standing. It's apocalyptic, like everything is just a pile of rubble. So these pictures are taken in 2017 when I went back this January. So I went out in 2012 to try and build the school. It got finished in 2014. The earthquake was 2015, and then this is 2017. So this is 2 years after the earthquake. This is the school they built next to our school while we were there, the unreinforced stone masonry one. Completely destroyed. This is just another picture of the village. No one's living in those houses. This is another school in the area. Again, it's unreinforced masonry with mud mortar. It's another school. This is another school as well, and this happens quite a lot, where the school's badly damaged, but despite engineers and government officials telling them not to teach their children in the school, they still do. And when you raise this with them, they just raise a valid point. Well, what do you want us to do? We don't have the money to rebuild it, and we don't have the money to repair it, so we're just going to keep the kids in it. That's another kid, another broken school. It's another broken school. There was a lesson happening in there while I was there. And this is how most of the community is now living. So it's these tin shacks they made from the metal roofs of their previous homes. And the idea was that this would just be a temporary solution until aid money came in and they could rebuild. Really hot in summer, really cold in winter. And this is what they call temporary learning centres. So again, these were temporary schools built from the remains of the old schools, mainly the tin roofing. And the idea was this would just be a temporary solution that saw them through until more money came in and they could rebuild the schools. But 2 years on, it's not too temporary anymore. These tents were provided by the Chinese government in the immediate aftermath of the earthquake, and the idea again was it was a temporary thing, and people would live in it until they had their proper houses back again. But this is 2 years on, and there's still communities just living in these tent villages, and this one's actually being used as a school, so there's children in there. But despite the fact the entire village was destroyed, our school survived, and it was the only building in the whole village that did. So you can see it here on the right, and it's got this sheer crack from the bottom corner there going down, which is the only damage to the school, which is quite impressive considering it was on the epicentre. On the left there you can see the temporary learning centre that's been built to house the children from the rubble at the back there that you can see, which is the school that they built when I was there. So despite vowing never to return to Nepal, the fact that our school survived and no other schools did made me reflect on the importance of earthquake-resistant engineering, and despite the difficulties in implementing it, it is worth it. And I also strongly suspected that engineers out there and NGOs out there do a lot of better job of implementing it than we did. So I applied to the Pai Lin Li Travel Award to go back this January and talk to practicing engineers and NGOs out there and find out what they do to overcome the problems that we faced. So what are the problems in implementing earthquake-resistant engineering? A big problem is building materials. So in 2012, when we tried to build our school, the concrete block production plant wasn't too far from our school site when we looked at it at a map in the UK. But when we got there, we realised there was one tiny winding mountain road, which was the only access to the school. And this road was continually plagued by landslides and these awful bus crashes. So when we ordered the blocks, after 2 days, I think it would have taken about 4 days if everything went to plan to get to the school on this road. But there was a landslide on the road, And when there was a landslide, what I didn't quite appreciate when I heard the news was that there's no other way to get the blocks. You can't go the long way around. And also there's no way to get machinery up there to clear it. There's also no way to get a workforce up there to clear it. So the only way you can clear the road of the landslide is by persuading the locals to do it in the evening when they finish working on the fields. So it took us a week to clear the landslide, and that was people just carrying rocks off by hand every day when they'd finished their day in the fields. So that delayed us by about a week getting the blocks to site. Then when we did get the blocks, as we were unloading them from the truck, they were just crumbling to dust in our hand because they were such bad quality. So we then had to order another set of blocks, which took another week to get through. And by this point, we were already 2 weeks behind and we hadn't even started yet. This is a problem faced by NGOs out there all the time. We were quite fortunate that we even had a road to get bricks to our school. A lot of NGOs work in communities that you can't access by road, so you can only get there by foot. The most obvious thing to do seems to be to use local materials, but all you've got locally is dry stone for unreinforced stone masonry. The local timber is really weak and poor, and you've only got mud for the mud mortar, so you inevitably have to carry things in, which you need for earthquake-resistant design, which is the sand, the aggregate, the steel, and the cement. So what are the solutions to this that people are using out there? One of the solutions is these CSEBs, which you've probably seen before. They're starting to use them in Germany and France, I think. They're called cement stabilized earth blocks, and they're starting to use them in Europe because they're sustainable in the sense they've got a lower carbon footprint because they have less cement in than concrete. And the idea is that you mix a little bit of cement in with earth that you dig from the site and then compress it with the force of a lever arm. And after 28 days of curing, you get these CSEBs that come out. No, sorry, this comes out of the machine straight away. You leave that for 28 days and then it has the same strength as concrete. That's what they claimed. I'm sure it's got the same strength as the Nepalese concrete because it's not good. But they come in all shapes and sizes, so sometimes they interlock like these ones for added strength, and this one's got holes in so you can run rebar through it. And the main point of this is you're just minimising the amount of material you have to transport to site because you're using most of the material from the site itself. They're also good because they're unskilled to produce them. So this NGO, whenever they go to a site to build a school, they employ the locals in producing the blocks for the school, so it provides employment for the time that they're there. In the more rural areas where you can't get cement or steel there just because they're too far away from any road to make it possible, some NGOs are developing these wooden ladders, which you use in the same way that you'd use the RC ring bands. So you put them at lintel level, sill level, roof level, and at foundation level, and they're supposed to tie the building together in the event of an earthquake. Engineers you talk to in urban areas are very cynical about this. They say it's not proven and they don't believe it works. But if you raise that with the people on the ground who are training the locals in this, they just say, well, what do you want us to do? Like, we're doing the best we can with what we've got, and I'm sure it's better than nothing. Something that some NGOs are developing, again, where there's no road access, is light gauge steel schools. So the whole school is made out of light gauge steel members. You then package up these members, put it onto the back of porters who carry it by foot to the place where they're building the school, and then you assemble it on site under the instruction of an engineer. It's often accompanied by instructions like an IKEA pack where sort of 1 goes to 1, 2 goes to 2. And these NGOs claim they can do it for the same cost as an RC school. So, and the NGO that I talked to, those pictures are from their design, they're working with a community that was 7 days walk away from the nearest road, so porters had to carry these steel members 7 days by foot before they could be assembled. One step further than CSEBs in terms of minimising the amount of material you need to carry to site is earth bags. So you just have to carry the bags to site and a little bit of rebar. You fill up the bags with the earth from the site itself, and then you run barbed wire between the courses of the bags, and you end up with these earth bag buildings. Big disadvantage of these is you have to provide these buttresses at the corners and along the elevations. And the reason that that's a disadvantage is all these new ideas are great, but you're often working with quite traditional communities that have been doing things the same way for a very long time. So there's often a big resistance to doing things in a different way. So the Earthbag NGO had stories of turning up to villages that have been completely desolated by the earthquake. There's nothing left. offering to rebuild their community, so rebuild their schools, rebuild their homes. The community is initially really excited, really grateful, and then they get halfway through the construction process and the community sees what they look like, and they don't look pretty. So that one on the left there, you can see it's got those weird yellow buttresses at the corners, and they see what the school looks like and they say, no, we don't want it. We don't want your school even for free. We'd rather go back to our metal houses and wait for another NGO to come along and offer us something better. So there's really strong cultural associations with buildings that you wouldn't necessarily expect. The only way to get around this really, and the solution employed by the Earthbag NGO and the CSEB NGOs, is to just build good examples. So just build as many good examples as you can, and as the community becomes more familiar with it as an idea, they're more susceptible to it. And the Earthbag NGO had a tactic of targeting the most prestigious member in the group, so a religious leader or the community leader, building them an Earthbag school, sometimes paying them to build them an Earthbag school. And the idea is once they accept it, the rest of the community is likely to be more susceptible to the idea. So we had a big problem with the workforce. Like I said, they couldn't read our construction drawings and they couldn't stack concrete blocks. And this is a problem faced by NGOs working in rural Nepal all the time. And they have got starkly different approaches to dealing with this problem. The most conventional approach is to train the local workforce. So you invest a lot of time, a lot of money in training people up on the job. This has got the obvious advantage of you're providing employment, and you're also giving them the skills they can go on and build their own earthquake-resistant buildings. But the big disadvantage of this is the quality of the final build is often quite poor because you're training people on the job. These are the kind of things they use to train people, so it's quite simple techniques of providing through stones where you've got 2 layers of stone masonry and limiting the size and widths of windows and doors. A more controversial approach taken by some NGOs is they say you can't trust the quality of any construction built by local labour, so they import in their own workforce to every site, who they keep on site until the school is finished, and then they move their own workforce onto the next site and do the next school. It's really good in the sense you get a really high quality build at the end from labourers you can trust, but as you can imagine it causes massive resentment in the community because they're not getting any training and they're also not getting any employment. And these NGOs, none of them use drawings, so when we turned up with our 2D construction drawings, it was such an error. They all use 3D images, sometimes computer generated, sometimes sketches, to get the ideas across to labourers on site. And this one NGO does this thing of, this is a reinforced concrete block school that they've built, and on the outside they've painted in red where the RC ring bands are, and then they've painted in black the lines going up where the vertical steel is in the walls, and they use it as a kind of real-life training aid. So whenever they're doing a new project, they take their workforce that they're training to a previous school that they've built and show them all the features in sort of real time, and apparently it works really well in getting the ideas across. In the wake of the 2015 earthquakes, the government produced a lot of material that shows people in rural areas how to rebuild back in a seismic resistant way. And all this material is isometric images and easy diagrams. None of it is 2D construction drawings like we're used to. I said earlier, the biggest problem, one of the problems we had was there was no perceived risk of earthquakes when we were there in 2012, so all the time and money we were spending on trying to make the school earthquake resistant was just seen as a waste of time and money. And this is entirely understandable because Nepal is struck relatively regularly by earthquakes and have been some quite bad ones within living memory, but the last one that was anywhere near as bad as the 2015 earthquake was in 1934, so it's just outside living memory. And this is what people said when I went back in 2017 this year. They said they knew Nepal had earthquakes, but they just never understood how bad it could be. And like I said, it's understandable because the last one's just outside living memory and there's no awareness training in these rural areas whatsoever. So since the 2015 earthquake, they've been running these awareness training programs in these rural areas, but the sad fact is they don't need the awareness training anymore. This entire generation has been scarred by the effects of this earthquake and they know how bad it is. And there's almost a frustration when they have to attend these awareness trainings that are funded now by the government, because they say, yes, we know the risk, but what do you want us to do about it? Like, we don't have the money to rebuild, and we don't have the skills to rebuild, so there's no point telling us there's a risk of an earthquake. We know that. Just give us the resources to deal with it. This was taken this January when I went back. So this is one of the wealthier communities in Sunkhani, which is the village that we built the school in 2012, or tried to. And this is one of the wealthy community members who's been able to build his house back, so he's had the money to do it. And with no training whatsoever, just copying what we did in our school and in other buildings he's seen, he's tried to implement some earthquake-resistant features. So you can see he's got some RC ring bins, he's got a little one at the top there. I don't think there's any rebar in there, but he's also got one midway over the building, and he told me I had one in the foundations as well. So although it's not ideal, you can see the philosophy has changed in the sense that people are very keen to rebuild back in an earthquake-resistant way now. Yeah, we had big problems with the local politicians, and I thought we were particularly unlucky, and we just had a particularly difficult group of local politicians. But when I went back, all the NGOs and all the engineers I talked to all said the number one problem in all their projects is local politics. So the way that Nepal works is the rural area is divided up into what they call village development committees, or VDCs. Each VDC is headed by an elected board, who in turn is headed by an elected chief. And these local politicians don't get any money from central government, so the only money that they can make is through the influence they wield. And it's almost accepted, not only amongst them, but also amongst the local community, that any work coming into the area should pay them some cut of the budget, just because how else are they going to get their money, as they put it, and the local community put it. So again, all the NGOs have very different approaches to dealing with this problem. Most conventional approach that a lot of NGOs take is what they call joint construction monitoring. So they aim to involve all the stakeholders as much as possible from the start of the project. So they take the local politicians, the teachers, the religious leaders, and they take them on these long, expensive paid trips where they tour them around the district, show them all the schools they're building, answer their questions, make them feel involved. And the idea is the more involved they feel, the less problems they cause. And it's generally meant quite effective. It's quite expensive and difficult, as you can imagine. Opposing, more controversial approach is just refuse to engage with it at all. So some NGOs, and they're the same NGOs that do the trick of moving their own labourers from village to village, also refuse to work in a village if the local politicians kick up any kind of fuss or ask for money. And there's so many villages in Nepal that need schools to be built for them. It's no problem for them to turn up. There'll be some sort of issue, they'll just move on to the next village, and they'll just keep moving around until they find a political climate in which they can build a school with no problems. Great, but then the people that lose out are the kids, because they don't get their school just because the local politicians are demanding money. So related to the previous point, corruption, we had senior officials in the area who were demanding, it was 30% of the project budget they wanted, and they wanted it in cash before they would let us work there. We didn't pay them the money, and that's when most of the problems in the project started. And this isn't surprising on hindsight, because when I went away, I looked into it, and Nepal is 131 out of 176 countries in terms of corruption, where 176 is the most corrupt. This was something put together by an organisation called Transparency International last year. I think they produce it every year. Yeah, so it's an incredibly corrupt country, so I shouldn't have been surprised. Again, there's very different approaches to dealing with this. Again, conventional and the nice way of doing it is just complete transparency. So these NGOs take the project budget and they give it to a board they form called the SME, or the School Management Committee, SMC. And the idea is this School Management Committee is then responsible for allocating the funds, so they employ the labour, pay the labourers, buy the materials, and at the end of the project, when they do a big opening ceremony for the school, they display the cost of everything, so like how many hours were worked, the cost of each hour, so the whole community can see how much everything cost and where every rupee went. And the NGOs that do this say the community is surprisingly savvy in terms of knowing exactly how much a school should cost and how much work goes into making a school. So apparently it's quite effective. Something that a lot of NGOs do, especially, so there's a law in Nepal that says any INGO, so an international non-governmental organisation, has to be partnered with a local NGO, which makes sense because you want to keep employment within the country, you want to keep expertise local, but a lot of INGOs take the attitude that it's not worth involving a local NGO because the risk of corruption is so high. So they get around this by putting a local NGO on paper, so on all the documents it looks like they're working with a local NGO, but in reality they're paying that NGO a small amount of money, and that NGO doesn't get involved in any of the projects. They don't even come to sites, they're not involved in any decisions, they don't come to any meetings, so it's purely a relationship on paper that allows them to work in the country. And then the most controversial but a very common tactic is just pay the bribes. So if you pay the people who are asking the money what they want, it does work, they do go away, and they do make your life easier. Big problem with this, obviously, is a lot of these organisations are aid organisations, so they're funded by donors back in America and the UK mainly. Donors don't generally like to see the cost of a bribe in their project budget. So people on the ground factor up the cost of materials or the amount of hours worked in order for the project budget to add up. So the people back, not sometimes even the people back in the office in Nepal didn't know this is where the money was going, but that is where it was going to make the people's lives on the ground easier. So the summary of my project was just a list of recommendations that I would make to anyone going to Nepal to build an earthquake-resistant school. I gleaned them from talking to people out there who do an incredibly good job of doing this, a much better job than we did. I'm not going to go through them, but I think what I mainly got from the project is I've always known that in structural engineering, a small part of it is the structural engineering and a big part of it is actually getting it built. But in projects like this, what I failed to appreciate when I went out there is the structural engineering is about 1% of it, and the other 99% is getting it built. You just have to wade through this quagmire of complexities and difficulties that you could just never anticipate when you're sat in your engineering office back in the UK. But I will say it is worth it. Like the fact that our school survived and no other ones did made me think it's worth wading through the complexities, just push through and do it. So, yeah, I'll take questions now. If you've got any.
Let me just say, before we go into questions, 15 years ago, I was president of this institution, and I raised the issue of corruption in my president's address. And some of my fellow directors were sitting in the seats in front of me, moving around. Wives were saying to them, "What the hell's Bob talking about?" And nobody talked about it in 2002. It was happening. It was happening. And at the Guildhall address, I eyeballed a number of consultants and said, "You know it's happening, stop it." And I got picked up on it, and I ended up giving evidence to Parliament in a special committee where they were trying to write an anti-corruption bill. Only our drafters could call it the corruption bill rather than anti-corruption. And I got grilled in Parliament, and a lot of the lawyers were condescending to me. "Well done, old chap, but you can't stop this." It ended up that we did get the Bribery Act. It's working now. There's still a lot of corruption around in the UK as well as in mainland Europe and elsewhere, but it's working. So have faith. It will begin, maybe not in our lifetime, but it does work, and you've got to have faith to do these things, and you've got to be brave to put your head above the parapet. So you've found out an awful lot more. In fact, I may actually ask you to come along to our anti-corruption forum to talk to guys of my age about what you found at your age, because it is so, so important. And we're trying to make sure that youngsters, I had some people a long time ago now from Scott Wilson who told me they'd come from Russia, and they said, "Well, that's how we do it here." Yeah, I said, "But you're not doing it here in Basingstoke." So, well done. Can we pick up questions? Sorry, I've taken up too much time, but I want to make this young man feel a little bit better. Questions, please. Gentleman at the back.
Alistair Norris from Risk Management Solutions. I was out in Nepal last year for a while, and I'm heading back out next Friday. Sort of ask a slightly open question, but something I noticed when I was out there. Do you think, generally speaking, one, that NGO or INGOs are doing more good or more bad to the communities that are out there? And then the second part is, be interested to know how many NGOs you spoke to, because the last count of charities on the ground that I heard was 1,500, and there were so many charities that, you know, they weren't earthquake engineers, they weren't really engineers, but they kept on telling you they were designing they were designing structures, and sort of that creates a massive issue in itself.
I guess on the first point, are they doing good out there? Are they doing more good than harm is the question. And admittedly, I was talking to engineers, so all the NGOs that I talked to employed structural engineers, and they were all designing seismic resistant buildings. And I'm worried I give them a bit of bad press here, because I've talked about the corruption and the way they deal with things. It doesn't come across as very well in here, but when I was out there, I mean, they don't need to be they're just building schools for children that are earthquake resistant. So everyone that I talked to, I thought was making a positive difference. They were doing it in very different ways, but at the end of the day, the kids were getting the school, and that's what they're aiming to do. I'm not sure about the NGOs that aren't structural engineers and what they're doing out there, because I didn't talk to them. But on how many NGOs I talked to, I probably talked to, I was doing about probably over 40 different NGOs. But like I said, they were all structural engineering NGOs, so they all were competent and did know what they were doing. If that answers your question.
Of course, what we've got to be able to do as society, and it's a big ask, is to try to improve the governance within each of these organisations. And if you can get one person converted to the cause, there's a good chance that it begins to roll. But by Jove, you've got to keep going at it, going at it, going at it. But I think the fact that your building stood that earthquake must show something to the local people, that there is a chance. But how do you get the materials there? Helicopters are for rescuing people in earthquakes, not for getting building materials back in. Other questions for Jacob?
Hello, my name's Rowan. How long do you think it will take for the infrastructure to reach the point that it was at in 2015? I guess. Do you think we'll ever reach that level again?
It's hard to say from what I saw when I was there, but things that were essential, so roads and things like that, were generally back as I believe they were before 2015. But the villages, the buildings in the villages, pretty much every one that I visited was just a pile of rubble. There was nothing left. And that was 2 years after the earthquake in 2015. So if you can't build it back in 2 years, I just can't see it happening any time in the next decade. They just don't have the money or the resources to do it. In Kathmandu and in some of the cities that I visited, there was a lot of rebuilding going on, and things were looking a lot more positive. And again, in the urban areas, they were rebuilding back in an earthquake-resistant way because they had the money to do it. But in the rural areas, it just felt hopeless, to be honest, when I was there. It was not an inspiring experience. So I'm not sure how long it'll take, but there's a lot of work to be done to get it anywhere near what it was like 2 years ago.
Just think of the way the money hasn't yet got to Haiti, far less been spent in Haiti.
Brian Ayling from the Education Trust. You said there were a lot of NGOs producing earthquake-resistant or allegedly earthquake-resistant buildings. Were they all using the same kind of technique, or was there some variation in the techniques?
The most standard one that they used, which makes sense on hindsight, and I wish I'd known before I went out there, was combining the traditional unreinforced stone masonry with reinforced concrete ring bands. So you use the local skills of constructing masonry schools, which they can do, and then you just combine it with the ring bands, which hold the school together. I'm not convinced that's that effective, because when I went back in 2017, a lot of people showed me schools that had been built using that tactic before the earthquake, and they were just piles of rubble as well. So there's sort of been a loss of faith in that building technique. So most of the NGOs out there now are opting for the reinforced concrete blockwork schools like our one, or those light gauge steel schools that I showed. They're going to be the next big thing, I think, because they're bringing down the cost of those and saying they can produce them for the same cost as a standard RC school. So they're the only two real solutions being utilised at the moment, is the concrete blocks and the light gauge steel.